Hey everyone, welcome to the Industrial Classroom, your go to place for learning the nuts and bolts of industrial tech in simple ways. Today we are diving into something that powers everything from car, brakes to giant machines, hydraulics. So, exactly, if we talk about hydraulics, then what is hydraulics? Simply put, hydraulics is the transmission and control of forces and movement using fluids, mostly liquids like water or oil. Okay, think about the hydraulics jack. When you press down on handle, for example, let me draw here a hydraulic jack. This is something looks like a hydraulic jack. Okay, when you press the handle down here, this jack lifts the vehicle. Okay, when you press down the handle, you are applying force to the oil inside. It is filled up with oil here in this portion, and this you are applying force to the oil inside, and this oil resists that force when you are pushing down, and it pushes the heavy load upwards with just a little effort. Cool, right? Now, one key thing about these fluids is that they are nearly incompressible fluids. Right, they are nearly incompressible. That means when you squeeze them, they don't really get smaller. Instead, the pressure inside rises, and that pressure can move or lift things. For example, let me consider a bottle filled with water. You have connected this bottle, right, and you have put a small slot in it, a simple hole on it. When you when you compress this bottle, if there is no slot here, then you might see there is an increase in the pressure. Okay, but if you have put a small slot here, then you can see with a large means a jet of water, we can say with a large pressure water comes out from this bottle. Okay, it is because it is incompressible. Rather, if it had been compressible, then the bottle would have compressed without even the liquid ejecting from this hole, right? So this is the meaning of incompressible. Next, in fact, oil only compresses by about 1% at really high pressure. Oil, it compresses 1% at around 2000 psi, which is a huge pressure you can determine. So for everyday use, we treat it as incompressible. Now, if we say that there are two main ways hydraulics are used. Okay, there are two main ways in which hydraulic power transmission can be done. The first is the hydrostatic power transmission, and the second is the hydrodynamic power transmission. So, what are the differences between these two? Hydrostatic power transmission, if we say like this in jack, as we have taken the example before, or hydraulic press, where pressure energy is used. Pressure energy moves a load slowly and with great force. So what is the effector here? The pressure energy moves the load. Okay, in hydrodynamic, we use the fluid velocity for high speed rotation. That is in case of water turbines. Okay, so when we come about hydrostatic, we know that the fluid is at rest. Okay, so this is my hydraulic jack, and here my vehicle is there. When I push this, there is no flow of water, as we can see. The pressure inside rises. The pressure inside the in the static environment, we can consider the system. If this is the system, there is no water moving out of the system or going into the system. Okay, so here we can say it that in, for example, like hydraulic jack, the pressure energy which we are providing is used to move the load slowly. But in hydrodynamic, if we consider this system, okay, for example, in turbine, you can see that there is flow of water inside the turbine and then flow of water outside the turbine. So the fluid velocity, what it is doing, it is used for high speed rotation of this water turbine. So this is hydrodynamic power transmission, right? Now, Industrial hydraulics usually deals with hydrostatic transmission when we talk about, and it has it has some awesome benefits. Now, what are the advantages of hydraulic system? As we know that in hydraulic system we generally use hydrostatic hydrostatics, and where do we use this hydrodynamic? That is in fluid mechanics and moving machinery. Okay, there we will study about hydrodynamics, but considering the hydraulic system we study about hydrostatics. Okay, so the first example is that it lubricates itself. The hydraulic system lubricates itself. There is no need for extra oiling because this the fluid present inside the system will is self lubricating. Second, it is simple and easy to operate even for beginners. Third, it allows smooth and sensitive speed control. We will learn all these things. Now the thing is that this is the just a basic class, and we will go and learn into depth about when we will study the hydraulic diagrams, the hydraulic circuits, then we will understand all of these things. Next, it is compact and lightweight equipment, unlike the mechanical equipments where these are very large equipments, right? Next, this is built in safety through pressure limit valves. Next is that it is easy to monitor with pressure gauges. Okay, so hydraulic system pressure can easily be monitored by pressure gauges. Next, it is positive drive with no slippage. But hey, you know that nothing is perfect. There are some challenges too, like heat from friction, risk of leaks, high initial cost, and fire hazards from oil and hoses. So these are the limitations. Friction causes oil heating. Next, we also need very careful design to prevent leaks. Small leakages may prove to be fatal. Remember, high initial cost. The hydraulic machinery is very expensive. Fire hazards due to oil and hoses. So, if we come here, then here is how a hydraulic system usually works. We have a pump driven by electric motor or diesel, right? It sucks oil from the reservoir. So this is the reservoir. Let me suppose this is the reservoir, and here it is a pipe, and here is a motor. Motor here connected here. Motor and pump. So it sucks the liquid from here. This is my liquid filled here. It is sucking the liquid, and then it converts this mechanical energy. The motor is something mechanical energy. We know that what is this motor? It converts electrical energy to mechanical energy. Now the mechanical energy of this pump, which converts the mechanical energy into this hydraulic energy by pressurizing the oil. Okay, the pressurized oil flows through pipes, valves, and then to the cylinder. For example, let us make a piston cylinder arrangement here. This is the cylinder, and the fluid enters inside the cylinder. This is just a sample drawing, although the circuit is very generic one. Okay, so this hydraulic cylinder or motor converts that hydraulic energy back into mechanical energy, and this converts back into mechanical energy, and then we can see that this pushes the piston and lifts heavy load. Okay, and that's your quick intro to hydraulic system. Next time when you see a forklift, a brake system, or even a bulldozer, okay, you will know how hydraulic power is behind the scenes, making it work smoothly and powerfully. Okay, so if we come across the real world examples, we could see that hydraulic jack lifting a car, excavator car movement, hydraulic brakes in vehicles, water turbines generating electricity, all are some examples of this hydraulic system. Now, this is a working diagram as you may see here. Okay, this is a working diagram of something which we had just taken into view. In any hydraulic system, everything starts with a pump. So this is my pump. Which one is my pump? This one is my pump, right? Next, we know that the pump is either driven by a diesel engine or a motor. Let us consider this as the motor. This picture is a very good picture taken from makeagift.com. Okay, so I had just collected it from Google. This is the pump. The pump is driven by motor. Here is the motor, and motor, or we can also have the diesel engine here. Right. Next, it sucks the oil from the reservoir. What is the reservoir? This is the reservoir. Remember, this is the reservoir. It's what is the function of the reservoir? It stores the oil. So when the pump is rotating in this direction, we can see that it is sucking the oil. Okay, it is sucking the oil through the filter. The filter or the strainer is nothing but it filters the oil before being sucked into the pump, or else it would make the pump as well as the whole circuit, what we can say, that there can be condensate or there can be impurities which needs to be filtered, right? This process converts mechanical energy from the motor into hydraulic energy. So here, this is the mechanical energy of the pump. It is getting converted into hydraulic energy, and the pressurized oil, after coming from the pump, it gets pressurized and is sent through the pipes. These are all, we can see, these are pipes. There are valves. Okay, there are valves here, feed valves, we can say, and they give the actuator and like hydraulic cylinder. So this is a, what we can say, a DC valve, direction control valve. Okay, and this is an actuator is nothing but similar to the hydraulic cylinder, where it converts back into mechanical energy to lift things. For example, if I place something on its top here, so it is being lifted. You can see this will move up and it will be lifted. So if we consider here, then what are the main components of hydraulic energy? Hydraulic energy is nothing but it is the sum of, let's consider hydraulic energy is the sum of pressure energy and velocity energy. What are these two? Pressure energy is caused due to pressure inside the system. Okay, and the velocity energy is caused because of the fluid motion. Okay, so pressure energy due to the pump, we know that this converts the mechanical energy into the hydraulic energy, right? So it also increases the pressure here. So this is the pressure is due to the pressurized oil, and velocity due to the fluid motion. Together they form what we call hydraulic energy. Now before moving into much depth, we need to clear some of the very basic concepts. The first one is understanding the building blocks, that is force and pressure. Okay, we have studied previously that force is nothing but it is the product of mass into acceleration. First, force is what changes the motion of a body. Okay, it changes the motion, that is, it can either stop the body. Okay, for example, this here in the image we can see that this is the lady and she is pushing the trolley, or we can say it as some car or trolley. So she is pushing, she is applying some force, due to which this trolley, which was initially at rest can move in this direction. Or if it was moving, the lady can just pull the trolley a little bit or just stop her motion, and the trolley will come in rest. So what is this? The force is nothing but a property which changes the motion of body. If something is at rest or moving at constant speed, it needs a force to change that. For example, when you push a hydraulic jack, you apply a force. Now, there are some units of forces. Main SI unit is the Newton, and then we have the CGS unit, which is kilogram force, and we have some FPS unit, pound force, or LBF. Okay. Now let us look at what is pressure. Okay, pressure is the amount of force acting per unit area. For example, this is the force acting per unit area. On which area it is acting, it is determined by pressure. The pressure is nothing but force by area, right? If you apply the same force on smaller area, the pressure is higher. For example, in case of needle, why are these needles so pointed? Because here the area is minimum. So you have applied the force here, and the area is minimum, so pressure is very high and it can do the stitching. Pressing a needle versus pressing a thumbtack can determine the difference between the pressure. Next, we are coming to the units of force and pressure. Let's look at some common units used in hydraulics. Poundal. For force, we use poundal. We use pound force, we use kilogram force, we use Newton. For pressure, similarly, we use PSI or pounds per square inch, we use kg per centimeter square, and SI unit is Pascal, and another unit we can say bar, another unit we can ATM. These are all of the units of pressure, right? If we go into the conversion of them, then we know that 1 Newton is equal to 9.81 kgf. Okay, 1 Newton is equal to 9.81 kgf. We must remember that. So therefore, this is nothing, we generally take it as 10, right? But its actual value is 9.81 kgf. So SI unit, and this is the kgf also is a different unit, but it is not an SI unit. It is a metric unit, we can say, or we can say it as the CGS unit. Okay. Next, when I come to 1 kg per centimeter is equal to 98,100 Pascal, and 1 bar is equal to 1 lakhs Pascal or 10 to the power 5 Pascal, and also we can say it is 14.5 psi. So these are some of the values. You must remember most of the important ones, that is the value of Newton, the value of bar. Okay. Next, moving on to the next slide, we know that, so are these slides the same? Okay, so we have studied all of these things. Okay, the units we have studied and the conversion we have studied, so no need to look at this all again. Now, what are the types of pressure? First, we must understand that the first pressure, which is the atmospheric pressure. Okay, pressure is just pressure. There are different types, you should know. The pressure exerted by the atmosphere at sea level, it is called atmospheric pressure, and its value is 14.7 psi or 1.01325 bar or 760 mm of mercury. You must remember it. Okay, and this is also equal to 10.3 meter of water. So why is 760 mm and 10.3 meter if both of these are fluids? See, mercury has a very higher density as compared to water, right? Therefore, if something has higher density, we should remember that P is equal to rho GH. Okay, if something has higher density, it means pressure capability is also high. So to undertake this pressure, it won't need much length, but we can write P is equal to rho G. If density higher, height smaller, so its density is higher. For mercury, the density is higher, so its height is 760 mm only, but in case of water, it is 10.3 meter. Also, some questions sometimes comes that what is the rise in water level for 1 mm rise in mercury? So there is nothing much we can do. We can just compare it with H is equal to P by rho G. We will go on in later phases, right? Now next is the gauge pressure. This is what the pressure gauge shows. It doesn't include atmospheric pressure, right? This is the device pressure or gauge pressure. This pressure gauge, the pressure gauge shown is the gauge pressure. Next, absolute pressure. Add atmospheric pressure to gauge pressure and we get the absolute pressure. Okay, so absolute pressure is equal to gauge pressure plus atmospheric pressure. Next, vacuum pressure. Vacuum pressure we know is less than the atmospheric pressure, right? In generally we can say it is in negative. Vacuum pressure is pressure below atmospheric. It's the difference between atmospheric pressure and the actual pressure or absolute pressure in a chamber. When this absolute pressure becomes zero, then we can say that it is absolute vacuum, right? Next, a very important topic, that is the Pascal's law. This is finally the foundation of hydraulics. So everything will start from here now. It defines that pressure applied to a confined fluid is transmitted undiminished in all directions, or we can say that it is transmitted equally in all direction. For example, if you have applied some force here, okay, if you have, this is the beaker and you have placed a lead here and then you are applying some force here. So the inside pressure, fluid pressure, will exert force equally in all direction, in every direction. It will not be that in one direction it will be 5 Newton and in other it will be 10 kilonewton. Okay, so it is not possible. So Pascal's law defines that pressure applied to confined fluid is transmitted equally in all direction. This means if you apply pressure at one point, it spreads equally everywhere. Okay, so the user, what does he do for the hydraulic press? He applies the pressure at one end. This is a photo taken from Encyclopedia Britannica. Okay, he applies the pressure and this fluid here applies pressure in all direction. So what is this? What is this weakest point here? The weakest point is this system, the mouth. Okay, because in rest other sections they are barricaded, so the pressure might not come. But since this is the weaker one, what we will do? It will lift the car up. This that what allows a small push on one side to lift the car on the other. Okay, so sir, there are some of the important examples which you must know: hydraulic jack, car brakes, press machines, and water distribution system. That's it for today's video. Now you know how pumps turn into energy, into hydraulic power, what pressure really is, and how Pascal's law make it all work. Okay, so it has, if you found this helpful, hit the like button, subscribe, and share this video with your classmates. In next video we will come much deeper concepts. See you next time in the industrial classroom. You can use this QR code, you can use this QR code here for supporting us to make some small payments that help us to build enormous content for you. Thank you so much. We will meet you in the next class.